So we have one more piece to cover in section 3.2, and that is annual percentage yield. I'll cover that and then do an example problem, and then we'll summarize what we've done today. So the annual percentage yield makes it much easier to compare different rates. Sorry, I did a restart here, so there we go. It makes it much easier to compare different rates. By converting everything to an annual term, basically a simple interest rate over 1 year's return. It makes it easy to compare, therefore, different compounding rates, different compounding periods, continuous compounding, and simple interest rates, all within the same terms for 1 year. And that way you can tell which is a better investment. There's two formulas that we have for that. One is for continuous compounding, and one is for just compounding. And we'll use both of these. So let's take a look at this. Problem number 54 from the book. We're not doing these homework problems. Oh, I need to turn off my personal camera here. One moment. There we go. So problem number 54. It asks, what is the APY, the annual percentage yield, for money invested at an annual rate of 3.05% compounded quarterly and 2.95% compounded continuously? Which investment is better? So for the first one, let's say 54A. So we have APY compounding. So we use equation number 7 equals 1 plus R divided by M to the M minus 1. This is basically just plug in the numbers. So we have 1 plus R, which is 0.0305, divided by compounded quarterly. There's 4 quarters in a year, so that's 4. 4 minus 1. Using your calculator and doing the work appropriately, and these are the numbers that you should be ending up with, you end up with 3.085%. And double check that on your calculator. These are the types of numbers you should get. Now we're going to take a look at B. For B, the question is compounded continuously, so we use the other formula. APY equals e to the R minus 1. Again, we just plug in the values. I see I have a typo here. E to the R, which is 0.0295 minus 1. Doing the calculation, that equals 2.994%. Now, let me correct my typo. Sorry. So we've got a typo right here. This should be E to the 0.0295 minus 1. Okay. Doing that calculation, you end up with the 2.994%. Now we can just do a straight comparison of these two numbers because they're in similar terms. So the quarterly compounding gives us an annual percentage yield of 3 plus a little bit percent, and the continuously compounding gives us a little bit less than 3%. So the better investment is that which gives us a higher rate of return, which in this case is the quarterly compounding. So let's take a summary of what we've done so far in this. Below is a graph. This graph shows a comparison between a simple interest rate, which is literally just a straight line that increases over time, of a rate of 7%. And then there's two more lines here. One is a black line and one is a red line. They both are at the same rate. So they both are 4%. The black line is continuously compounding, and the red line is semi-annual compounding. If you look at it, you'll notice that the compounded ones eventually become greater than the simple one, even though starting out one is 7% and the other ones are 4%. Looking at it closely, it looks like it happens at about 26 years. Now, when that happens depends a lot on the rate of return. So over time, compound interest always beats simple interest. For this example, in about 26 years. The difference between the compound interest and the continuous interest depends. It depends a lot on the value, the R, what is the rate, and on M. So in order to compare those two, we have to use APY. So every time we see and ask for a comparison, we use APY for these. So thank you. Hopefully lecture 1 has gone very well for you.